Yes, good morning. Hello students, how are you? Today we present with the topic significant figure of the chapter Some Basic Concept in Chemistry. Significant figure is very important topic in this chapter and few rules we have to know to find out the significant figure in a number. What is significant figure? Previous day we have discussed. Significant figure means all certain digits plus one doubtful digit is known as the significant figure. All certain digits plus one doubtful digit is known as the significant figure. My dear students, significant figures are meaningful digits which are known with certainty. There are certain rules for determining the number of significant figures. All non-zero digits are significant. Very important things like as 256. If I tell the number 256, 256, how many significant figures are there? That is 3 significant figures. Because 2 is non-zero digit, 5 is non-zero digit, 6 is non-zero digits. So 256 is, there are 3 significant figures. Next I am going, zeros preceding the first non-zero digits are not significant. If I take the example 0.03, 0.03, how many significant figure? 1. Because 0.0, this 0 is preceding of the first non-zero digit 3. So 0.03 and there is only one significant figure. 0.056, how many significant figures? 2. 0.0056, how many significant figures? 2. 56. Before 56 there are 2 zeros which are non-significant. So my dear students, in the number 0.0056 there are significant figures too. Now zeros between two non-zero digits are significant. Zeros between two non-zero digits. If I tell you 2003, 2003, that is 2003, how many significant figures? There are 4 significant figures. My dear children, 2 and 3 are non-zero digits. And between 2 and 3 there are 2 zeros. And these 2 zeros are significant. So in the number 2003, there are 4 significant figures. My dear children, next I am going to the next rule. Zeros at the end or right of the number are significant, provided they are on the right side of the decimal point. But if otherwise, the zeros are not significant. If I tell zeros at the end or right of the number are significant, suppose if I tell you 5.003, 5.003, another 100.0, 100.0, how many significant figures? 4. 100.004, how many significant figure? That is 5 significant figures. So 100.0, 4 significant figures, 100.00, 5 significant figures. So zeros at the end or right of the number are significant. Next, during addition and subtraction, the result cannot have more digits to the right of the decimal point than either of the original numbers. Another important rule, students, for any counting numbers, suppose 20 balls, how many significant figures? Infinite. Because we can write 20 balls means 20.00, 20.0, 20.000, 20.0000. So you can give many zeros are there. So what are the significant figures for the counting numbers? Total significant figures, that is infinite. So rule number 2, 3, 4, 5. Another rule, that is for counting numbers. These are 5 rules that is very, very important. So significant figures, I think I will give few questions related to the significant figures and I hope you understood and you can do it. Now students, few important terms I want to clear to you, very very important for this chapter and to do the numericals. So I am going to clear the few terms here. First one is Avogadro's constant or Avogadro's number. 6.022 into 10 to the power 23 is called Avogadro's constant or Avogadro's number. Previous day we have discussed the mole concept. And what is mole? Mole is the collection of Avogadro's number particles. If I tell you 1 mole of water, it means that 6.022 into 10 to the power 23 water particles. 1 mole is the amount of substance that contains as many particles or entities as there are atoms, exactly 12 gram of the C12 isotope. The mass of 1 mole of a substance in gram is called its molar mass. What is molar mass? Mass of 1 mole of substance in gram is called its molar mass. My dear students, I told you that water molar mass is. What is water molar mass? Anyone, can you tell me? What is the molar mass of water? Yes, absolutely correct. Your answer. The molar mass of water is 18 gram. Molar mass of water is 18 gram. The molar mass in gram is numerically equal to the atomic, molecular or formula mass in unified mass. We express the molar mass. Molar mass, I told you. If I tell you, what do you mean by the molar mass of oxygen is 16 gram? I explained. That is, 1 atom of oxygen is 16 times heavier than 1 by 12th of the mass of 1 atom of C12 isotopes. So now, with the relation of mole concept, what is molar mass? The mass of 1 mole of a substance in gram is called its molar mass. The molar mass in gram is numerically equal to the atomic mass or molecular mass or formula mass. Now students, molarity. Molarity, molality, mole fractions, mass percentage, these are the unit of the concentration of the solution. Previous day I discussed in the class. So molarity is the number of moles of solute per liter of the solution. And what is the unit of molarity? Moles per liter. This is very important questions in the exam. The question is coming frequently. What is the unit of molarity? So you note down in the notebook, the unit of molarity is moles per liter. Molality is the number of solute present in 1 kg of solvent. So what is the difference between molarity and molality? Molarity is the number of solute present in 1 liter of the solution, but molality is the number of solute present in 1 kg of solvent. Another thing, students, molarity depends upon temperature, but molality does not depend upon temperature. So these are the 2 points for the difference of molarity and molality. Now atomic mass. Atomic mass, I told you, atomic mass means that is how many times an atom of an element is heavier than 1 by 12th of the mass of 1 atom of C12 isotopes. Now students, molecular mass, I told you, it is the sum of the atomic masses of the atoms present in a molecules. Suppose if I take the molecules water, H2O, what is the molecular mass? That is the molecular mass means sum of the mass of 2 hydrogen atoms and 1 oxygen atom. That is 2 plus 16, that is 18 grams. Molecular mass expressed in gram is called gram molecular mass. Next students, formula mass. Formula mass means sum of atomic masses of all atoms in a formula unit of the compound. Specially, formula mass is used for the ionic compound. An ionic compound is the compound of metal and non-metal, you know students. So formula mass, molecular mass, atomic mass, molarity, molality, mole concept that we have discussed. Empirical formula. Empirical formula and molecular formula, another topic of this chapter. What is empirical formula? Empirical formula represent the simplest whole number ratio of various atoms present in a compound. If I take the example of the water, students, what is the formula of water? Yes, absolutely correct, H2O. What is the formula of hydrogen peroxide? Yes, absolutely correct, H2O2. In both these two compounds, two elements are present, hydrogen and oxygen. But the ratio of atoms of hydrogen and oxygen in the two compounds are different. So, empirical formula, if I tell HO, empirical formula of water is HO, empirical formula of hydrogen peroxide HO. But the correct number of atoms of hydrogen and oxygen is not present in the two compounds. Correct number of atoms. In water, 2 atoms of hydrogen and 1 atom of oxygen combine to form water. In hydrogen peroxide, 2 atoms of hydrogen and 2 atoms of oxygen present. But if I tell you what is the empirical formula of hydrogen peroxide, and if you tell HO, but how many atoms of hydrogen, how many atoms of oxygen are present, that is not given in the empirical formula. Empirical formula actually whole number ratio, that is H2O2. What is the ratio of hydrogen and oxygen here? That is H2O2 ratio. But the molecular formula means the correct number, the accurate number of atoms of the elements present in the compound. The empirical formula is the simplest whole number ratio, not the correct number of atoms. Simplest whole number ratio of various atoms. But molecular formula, exact number of different types of atoms. So what is the difference between empirical formula and molecular formula? Empirical formula gives the simplest whole number ratio of different atoms. But molecular formula gives the exact number of atoms present in the molecules of a compound. If I tell HO is the empirical formula of hydrogen peroxide, but H2O2 is the molecular formula of hydrogen peroxide. So empirical formula and molecular formula we have to know, very very important. And molecular formula is equal to N into empirical formula. Molecular formula is equal to N into empirical formula. For calculating the empirical formula, for find out the empirical formula, that is, we have to prepare one table, and that we will discuss in the class. So empirical formula and molecular formula we have to know. If the mass percent of various elements present in a compound is known, its empirical formula can be determined, where N is a simple number and may have values 1, 2, 3 molecular formula. So molecular formula mass is equal to N into empirical formula mass. N into empirical formula mass. Again I am repeating, what is the relation between empirical formula and molecular formula? So molecular formula mass is equal to empirical formula mass. And N equal to molecular formula mass by empirical formula mass. Now students, top formula of this chapter I want to tell you to solve the numericals. Number 1. Mass percent of an element equal to mass of that element in the compound divided by molar mass of the compound into 100. If I tell you what is the mass percentage of carbon in the compound carbon dioxide, so what will be the answer? CO2, it is the formula of carbon dioxide. So mass percent of carbon is equal to molar mass of carbon, that is 12. So 12 into 100 divided by 44. 44 is the molar mass of carbon dioxide. So 12 by 44 into 100, this will be the mass percent of carbon in the compound carbon dioxide. Second, mass percent of the solute equal to mass of solute divided by mass of solution into 100. Number 3, mole fraction. Mole fraction equal to number of moles of a particular component divided by total number of moles of the solution. Suppose if in a solution there are 2 components, if in a solution, and mole fraction equal to number of moles of a particular component divided by total number of moles of the solution. Students, one question I am asking you. My question is, what is mole? What is mole? Mole is the Avogadro's number of particles. Another definition of moles, I told you, mole equal to given mass by molar mass. Mole equal to number of particles divided by Avogadro's number of particles. So mole concept related many numericals you have to do using the formula. mole equal to given mass by molar mass. Mole equal to given number particles divided by Avogadro's number of particles. And mole fraction equal to number of moles of a particular component divided by total number of moles of the solution. Next formula, molarity, number of moles of solute divided by volume of solution in liters. Next is molality, number of moles of solute by mass of the solvent in kg. Next is moles of an element, given mass of the element divided by atomic mass. Mass of one atom equal to atomic mass by 6.022 into 10 to the power 23. How this is possible, I am explaining now. You know, students, atomic mass means mass of Avogadro's number of particles. Suppose there are 6.022 into 10 to the power 23 particles present in 12 gram of carbon. Atomic mass of carbon is 12 gram. So, 1 mole of carbon equal to 12 gram carbon, and 1 mole carbon equal to 6.022 into 10 to the power 23 carbon particle. So we can write that mass of 6.022 into 10 to the power 23 carbon particle equal to 12 gram. So 1 carbon particle mass equal to 12 by 6.022 into 10 to the power 23. So mass of one atom equal to atomic mass divided by Avogadro's number. Moles of a compound. Next number 8 formula. Moles of a compound equal to mass of compound divided by molecular mass. And 9. Mass of one molecule equal to molecular mass by 6.022 into 10 to the power 23. 7. Number 7 formula. Just attention, students. Mass of one atom equal to atomic mass by 6.0. So, 7 student attention, formula number 7 and 9. Mass of one atom equal to atomic mass by 6.022 into 10 to the power 23, and mass of one molecule equal to molecular mass divided by 6.022 into 10 to the power 23. The mass of one atom and mass of one molecules you have to know. So these are the important formula to solve the numericals. So this is the end of the chapters, different topics we have discussed. So thank you, students, for listening me and watching the video. I hope you will do all the tasks that I have given to you. Thank you so much.